Hello. In this video, I'm going to show you how to assign materials in OnShape and edit their properties, specifically their mass or their density. Right, so this video is focused on the F1 in Schools program. It's obviously critical that you can accurately predict the weight of your car as you are designing it and not just weigh it after it's been manufactured. There's really strict guidelines about how much the cars can weigh. It's different in the different classes, but you really want to be aiming for as close to that as possible. If a car is heavier, it's not going to go as fast, and then there's penalties if the cars are not heavy enough or they're too light. So to work out how heavy the car is, we need to know a few things. We need to know how much the wheels weigh, and we can just weigh a wheel kit for that. That's pretty easy. And then we have to calculate how much the balsa wood body is going to weigh. To do that, we need to know the density of the balsa wood. So to work out density, you need to know mass and volume. So let's dive into that. The technical regulations shows us the size of the piece of balsa wood and some of the features. And I've done some maths on the side here that I'll talk you through. So volume equals length times width times height. So for this case, we're going to have to calculate the volume of the entire block of balsa wood, and then we're going to have to subtract the tether groove and the kind of cut out hole for the CO2 canister as well. So let's do that. Length is 225, and then we've got the height of 50 and the width of 65. So overall, the volume of the balsa wood block before subtractions is 731,250 millimeters cubed. Now we've got this groove here, so that's 6 millimeters by 6 millimeters by 225, which works out on this line to be 8,100 millimeters cubed. And we've also got the CO2 canister hole. So that's a cylinder, which is pi times r times the height. That's the formula for the volume of a cylinder. So pi times 9.5, half of this, times squared times 52, the height or the depth, equals 14,743.49 millimeters cubed. So overall, here we go. This is the volume of the balsa wood block, 708,406.51 millimeters cubed. Now, this doesn't change. All of the balsa wood blocks have the same volume, so we can work with that number every time. However, they all have slightly different densities. So we want to weigh the specific piece of balsa wood that we're planning on using. I'm working with a balsa wood block that weighs 120 grams. Right? Okay. So density, the symbol for density is a lowercase b. Density equals mass divided by volume. We've got everything we need to work that out now. Our mass in grams is 120, and our volume in millimeters cubed is 708,406.51 millimeters cubed. We do the maths and we get this number, 0.00016939 grams per millimeter cubed. So that is the density of my piece of balsa wood that I'm using for this example. I could write it in scientific notation. OnShape does do that. All right, so let's double check. I've drawn this piece of balsa wood in OnShape, and now I'm going to assign material to it and get it to calculate the weight of the balsa wood. It should come out at 120 grams. So I click on the part, and then I can right click and I can assign it a material. OnShape has a whole library of materials that you could choose from, all sorts of different things. They even have one for balsa wood. Okay, and the density there is 1.6. E -4, move the decimal place 4 spots. It actually works out almost the same as this. It works out as 0.0016. Ours is 0.0016939. So it's close, but not close enough. We can't change the density. It's linked to that balsa wood in their library. So we're going to create a custom material. Maybe we call it custom balsa. Doesn't really matter. And then we can put in the density that we want it to be. 0.0016939. We can click accept. All right, now to check the weight, I again choose my part, and then on the bottom right hand corner, I can click display mass properties. So here it tells me the volume, which is good. It's the same as what I calculated. And it tells me the mass, 119.997 grams. Very close. That's within the rounding on our calculator. So that'll definitely work for us. So good. We worked out density and we checked that it worked. All right. So if we look at the car now, let's put this into practice. Part 5 is my balsa wood body. So I'm going to assign a material to that. I'm going to call it custom balsa 0.0001699. Accept. And then for my wheels, what I'm actually going to do is select them all, assign a material, and then I'm going to make sure that I've got none selected, because that way they don't have a density. There's no weight assigned to them. So that's good. Should be none by default. There shouldn't be a material assigned by default. So now if I look at display mass properties, I've got to select the parts. So if I select everything, parts 1 to 5, the car and the wheels, display mass properties, I'm seeing 54. Oh, I've skipped a step. Sorry. We have to assign the weight for the wheels. Yep. So if I look at one of the wheels and then I look at its mass properties, what I've done here is I've just clicked override. So really, my wheels don't have any mass. So all the other wheels, if I click on a wheel and display its properties, it doesn't have a mass because I didn't assign a volume to it. I didn't assign a material to it, and so it didn't assign a mass to it. But what I've done is selected one of the wheels, in my case, part 4, and I've assigned a mass to that wheel. So this mass should be whatever the weight of the wheel kit is. I don't have that in front of me. I'm taking a guess at about 15 grams. So by overriding it and assigning a mass to one of the wheels, I've guaranteed that the mass of the wheels is right and accurate, and then OnShape is calculating the mass of the piece of balsa wood. So I could look at part 5, my balsa wood body, and if I click mass properties, I'll see it's going to weigh 39.138 grams. And if I add then the mass of that wheel, so if I select all of the parts and click display mass properties, it will add the mass of the wheel to the mass of the balsa wood and get me to 54.138 grams. So that's pretty close. Obviously, it's a little bit overweight, and I've got a couple of options. I could change my design, but I could also potentially select a piece of balsa wood that was less dense. So back over here, if my piece of balsa wood weighed 115 grams, for example, then it would reduce the density of the balsa wood, and I could come into OnShape and update that, and it would change the weight. I'm not going to do the calculations again, but if I edit my material and I say 0.00001 6158. I put that in as my density. We'll see what that turns out. And then I check it again. Okay, so I've brought it down to 51 grams. So yeah, by choosing the right piece of balsa wood, that is the density that matches your design, you might be able to get really close to something that works well for you. Just quickly at the end, you'll notice that I'm working in grams and millimeters. If your OnShape isn't set up in grams and millimeters, you can quickly change that. Go to my account, go to preferences, and then you can change the units from, it might be in kilos by default. I'm using grams and millimeters. Great. I hope that was helpful and gave you some tips about working with materials in OnShape.